Hello everyone. In this video, I am going to explain the Verilog implementation of the four-way interleaved multi-threading processor and also the simulation in which we have run four different bubble sort programs on each thread. First, I will go through the Verilog file. In this design, we have updated the previous lab's 5-stage pipeline processor which had late branch design and also which had hazard detection unit and forwarding help. But for this design, we have removed hazard detection unit and forwarding help as we are not in need of those units anymore. Because as for the four consecutive cycles, four different threads will be running and there will be a no RAW dependencies. So we removed all hazard detection unit and forwarding unit help. For this design, we added four different pieces for each thread and also four register files. That is 128 bit depth, 128 depth register file, which is divided into four sections for each thread. First, I will go through the PC design. This is for PC 0, this is for PC thread 1, this PC 2 is for thread 2, and PC 3 is for thread 3. Each PC is having an enable signal. Whenever it is high, then only updation of PC will happen. Here we can see first priority is given to branch or JLR instructions which are executed at the memory stage because they are the senior most instructions. When branch or JLR instructions are true, that means they are taken. And if thread at the memory stage is 0, then PC 0 will get implemented. If branch or JLR instruction is true and thread 1, 2, or 3 is there, then corresponding PC will get updated. If branch or JLR instructions are not taken and JL instruction at the ID stage is taken, then we will compare thread at ID stage. If it is 0, PC 0 will get implemented. If it is 1, PC 1, or if it is 2, then PC 2. If it is 3, then PC 3 will get updated. And at At last, third priority is given to the thread at IF stage. At the IF stage, if thread is 0, then PC 0 will get incremented by 1 in the next cycle. This is this corresponds to all PCs. And at the at the instruction memory stage, we have implemented a mux which selects out of 4 PCs, 1 PC based on the thread. Now I'll go through the register file. In the register file, I have implemented 128 depth register array in which it is a 7-bit address. In the pipeline design, we can see still we have given 5-bit address as per ISC, but we have appended it with thread value at ID stage so that each 128 depth register array is divided into 4 different arrays, each of 32 depth. And thread of that particular instruction is moved along with the instruction in every stage to help for the updation. Now I will go through the simulation. In simulation, we can see we are loading the register files from the data memory with the different values that we have preloaded. This is 10 is for thread 0, 42 register file is for thread 1, 74 address register file is for thread 2, and 106 is for thread 3. These are the initial addresses of the register files storing the for storing diff unsorted numbers. For thread 0, we can see at 10th location 150 is stored. Then for 11th register file 100 is stored. For 12th 190. For 13 123. And for 14 is stored. We will come at the end. Here we can see at the 10 after sorting at the 10th location 14 has come. At 11th register file 100 has stored. Then for 12th 123 and for 13 150 and for 14 190. This is for thread 0, and for thread 1 you can see for 42 26 is stored, and 43 112 is stored, and 44 145 is stored, and 45 162 is stored, and at 46 202 is stored. We can see all the four different bubbles or programs are ran successfully. Yeah, thank you.